Hello everyone. I'm Neil Mitchell, one of the co-captains on Don't Blink, and this is First Tech Challenge Rookie Rescue. Here, all of you guys can join and listen to our 10-minute presentation about today, servos and power transmission. And then after, we'll get into a deep dive on any questions that you guys have, and then go from there. I'm joined today by other members of Don't Blink. If you guys want to introduce yourselves really quickly.
Yeah, hi. I'm Arnav. I'm also one of the co-captains on this team, and I'll be helping answer any of your guys' questions and like helping present and stuff.
I'm Arav. I'm also one of the members of Don't Blink. I'll also be helping answer questions.
Yeah, I'm Vikram. I'm also going to be helping answer questions.
Harsh is also
I'm Arsh. I'll also be helping out.
Okay, so let's hop right into the slide deck. I think people are still rolling in, but that should be okay. Okay, let's right into it. Okay, so today we're going to be talking about servos and power transmission, how they can be important on your robot and where to use them and all that good stuff. So let's hop into what a servo actually is, right? A servo, in simple terms, is kind of like a mini motor. Basically, it's for controlling position and speed. You can use the position of the servo to reach specific positions. It does not have that full 360-degree range, but you can put it into a different mode called CR or continuous mode, where you can have the servo running that entire 360 degrees. And then also it's controlled by signals to go to a set position. Arnold, do you want to take this slide?
Yeah, sure. So servos are they're actually incredibly useful in FTC. So the limit that you can have of servos and motors on your robot, if you didn't know, is you can have 8 total motors max, and you can have 12 servos max. But obviously some servos can be very heavy, so it's important to be very like concise with your usage and be very scarce with them. But the most common applications in FTC you can see are in arms. We've included some pictures of some CAD here, or computer aided design, for those who don't know. You can see they can be used to move sets of arms. They can be used for claws. They can be used for turrets, even to give you that sort of like almost 180 degree of motion, or even more depending on your usage. And they can even be used for small extensions on your robot, which is even more pertinent this season because there's an extension limit. So there are plenty of uses, and they're extremely useful.
Yeah, let's hop into the next slide. Arsh, do you want to take this one?
Yeah, so to mount stuff onto servos, there are many different servo attachments that you can use. So some of these are gears, which would be used for power transmissions, which we'll go into later. We have hubs, which you can use to mount onto parts. And then we have arms, which can control stuff like linkages and just like are also pretty useful. And then there's shafts. So I think shafts are a relatively new part, and you can mount stuff like pulleys and gears and just like a lot of good stuff on them. So yeah. And something to note is that you can also use 3D printed parts, and you can put gears or mount them to hubs on the servos. And then also, as Neil mentioned at the start, there's different modes for this servo. So there's continuous rotation, then there's also set position. So to switch between the modes, you'll need some sort of servo programmer to use that. And then also, um, the servos can receive different levels of power. So the control hub has like the default amount of power, but there's something called a SPM, which will basically when you can plug into your servo into that, and then it'll become more powerful because it's getting more power from the SPM.
Yeah, one quick note is that R said you can press fit into 3D printed parts. We want to tell you that only do this if it's absolutely necessary. This isn't like a traditional approach that you would see, and it's not really the right way to do things. But this is the first tech challenge, so when things get desperate, you might have to do things like this.
Yeah,
And
so the
also
reason
yeah.
Yeah, so the reason you might want to do this is because like you can't 3D print the splines on the servo because like the teeth of the servo spline are really small. So if you ever have to do something like this would be the way to do it. Although it's heavily not recommended, I guess, to do
Yeah,
it.
definitely try to use the attachments that you can find off the shelf instead of 3D printing some
Yeah.
weird extraneous part. And also the SPM, or this is Rev Robotics Servo Power Module. We say only use that for Axon servos, so we'll talk about that a little bit later. But these are kind of just like the #1 servo in FTC right now in terms of torque and speed. But they are expensive, so definitely mind that when trying to purchase these. But
So
it's you can give extra power to your servos if they do need it under certain circumstances.
yeah, for sure. In the bottom right, you'll see an Axon servo, and then in the top, you'll see a Go Builder servo.
And
They're
when we mention spline, for those who might still be a little confused, it's that little thing that Neil's cursor is on. It's like a little circle and it has these very fine teeth in it. And that's where the power output and torque output of the servo comes from.
and it basically spins just like how a shaft on a motor would.
Yeah.
Just to also let you guys know, these are all Go Builder COTS parts, but you're often able to find these attachments in just different manners at different vendors that FTC often uses. So yeah. So now let's hop into some do's and don'ts of servos. For a do, you definitely want to use the appropriate power. So if you are using an Axon, or an Axon servo, you usually want to use a servo power module because it allows you to obviously move a lot quicker and it makes just all your mechanisms a lot faster and a lot more strong. You always want to test your servos before using them because oftentimes they can be finicky. I think during our Freight Frenzy season, we went through so many servos. It's not even a joke. And then you
33 servos to be exact.
33
So
servos.
definitely make sure that, run some basic math calculations before you throw a servo on your robot and make sure that it can actually handle, the torque that you're demanding of it or the speed that you want it to operate at.
Mhm. And that's kind of ties into this, right? Use appropriate servo load. So you want to make sure that you're using the right servo for the right application. So if you are carrying something that's really heavy or don't really care about the speed of that mechanism, maybe you're going to use a torque servo. But let's say you really need the speed. So if you have a swivel at the end of your arm, maybe you'll use a speed servo. And then from there, to make it even stronger, you can gear up and have more torque. So you want to make sure that you test out your servos, look at which servo you're going to use for which mechanism, and then also try to make your mechanisms not too heavy so that the servos can handle it. You want to securely mount your servos and finally check and secure all connections because oftentimes your servos are going to be going really far away from the robot and the hubs, right? So you're going to have to use extension wires. And those extensions can often get cut or come loose or come apart. So you want to make sure that maybe before every match, you check those. And what Don't Blink does is put zip ties around those connectors to ensure that they don't come out. We don't have a picture of it here, but maybe we can find one for later. In terms of don'ts, Arnav, do you want to take this?
Yeah, sure. So a lot of the don'ts we kind of already talked about while talking about the do's, but I can just briefly cover it. So what you don't want to do, and this is more in terms of your robot is built, your robot is operating, you don't want to ignore irregular sounds from the servo because although the motors we use in FTC might not always have like a gearbox, the servos do. There's a very complex overlay of gears inside of the actual servo. So if there's anything wrong with it, you don't want a gear to be warped or have a tooth missing or something like that. You want to get on that ASAP because you don't want to enter a competition venue with a broken servo, right? Along with this, you don't want to ignore smells of burning or smoke coming from the servo. This does happen. It happens maybe a little bit more frequently than you think when you kind of miscalculate like the torque and speed you demand of the servo. And we have had servos burn before. So if that happens, also replace it as quick as possible. Don't try to go in, oh, I can fix this because it's like not always that easy. So there's better to just replace it. We also said this, overestimating the torque capabilities and the load. Like if I'm putting something super heavy on like a speed servo, right, to move up and down or like 90 degrees or something like that, you don't want to do that because your servo is going to break much, much quicker and it might even break the first time you try to move it. And that's also why it's important to securely mount your servo. So if you guys search up like servo blocks or something from GoBuilda, it's like this like rigid set that they give where you have standoffs and like metal parts to actually make sure your servo is mounted properly, because if it's not, that can also lead to your servo breaking more easily. You want to make sure it's very securely mounted and that the torque is directly going to the mechanism. Along with this, you don't want to use external electronics. So a very popular servo is the Go Build a Servo, and you don't always need to run like external electronics like the servo power module or something like that on the servo, because you can get what you demand out of the servo just by having it mounted on your robot. So definitely don't use that unless you absolutely have to, like for axons or something. This is another thing, especially for rookies, keep this in mind. You will see that a lot of servos, because there are tons of different vendors, they will have a different teeth count. So remember we were talking about the spline and how much teeth that they have. Some servos have 24 teeth and some have 25. It's a 1 tooth difference, but it's really important when you're ordering your attachments or something like that. So definitely make sure to double check like how many teeth you have, because you don't want to end up forcing the wrong tooth count like attachment on, like, you don't end up forcing like a 24 like tooth attachment on a 25 tooth servo, because that's just going to break both of them. And then, finally, you don't want to ignore any exposed wiring or anything like that. We saw some of that this season where our intake attachment at the state tournament, it kind of malfunctioned and it broke and we ended up losing. And then later we found out that the wire was actually like melted with the other 2 servo wires. So
So
definitely check up on that and get that switched out. And then finally, you also for those of you who did FLL, you probably know this as well, but you don't want to move the servo gears with the attachments with your hand, because that can lead to the gears being worn out or the servo burning out, and you don't want to do that. You only want the servo to move with the power that you give it.
yeah, that when we had those 2 exposed wires, it ended up actually going all the way back to our SPM or servo power module.
Oh
And
yeah,
and then that also melted, and then we ruined that. It was like, it's not only like your robot's not working, but it's also you're wasting money because these things are expensive. It's
yeah.
robotic.
It's like a short circuit, and then our servo power module started smoking, and that's not good. So everything was kind of in shambles. So
You also don't want to like set everything on fire. So just
yeah, so definitely make sure everything is like up to code. You want to make sure your wires are fine, your servo power module is fine, your servo health is fine. So yeah.
Right. So let's get into what power transmission really is, right? So on your robot, you're going to have motors and you're going to be powering different mechanisms, right? So this is called power transmission, this concept. There are many different ways to do this, right? You can have if we had a wheel, for example, right? And this was our wheel, it spins like this, right? We could power this wheel directly, or we could have our motor here and then power it through a belt or or through chain or through plastic chain, and we could use pulleys and sprockets, or we could even use a rack and pinion, or we could gear to that thing that's moving, right? So there's different aspects to each of these different types of power transmissions because they offer different advantages and disadvantages. So for example, in terms of direct driving, right? If you're always direct driving your mechanisms, if one of your mechanisms is mounted really high on your robot, then you have that heavy motor all the way up, all the way at the top, and then it causes you to maybe fall back when you're extending backwards. Or, for example, I don't know, if you have your motor, if you're direct driving your wheels and your motor's at the front of your robot, you get rid of all that space that you could use for your intake. So that's why we kind of like to say that you shouldn't direct drive as much as possible, but in some cases it's all right. So we'll get into that in a little bit. There's sprocket and chain, there's belt and pulley. For belts and pulleys, you have round pulleys and belt and teeth pulleys. So an example of a round pulley is here and a teeth pulley is here. This is the belt that would be paired with this pulley. Gears, you can use bevel gears and these types of gears, and then rack and pinion is where you have a gear running on a little rack, which has like a bunch of teeth. We can show you a video of how that works in a bit too. So how do you actually use power transmissions? Arsh, do you want to take this one?
Yeah, so there's many like different scenarios where you would use power transmissions for different applications. So one of the main uses of power transmissions is to change your torque and speed ratios. Because like, let's say for an intake, you want something that's really fast, then you'd probably and you only have like a 435 motor, right? So that might not be as fast as you like. So what you can do is you can have like a belt or a gear that's geared down so that like the output is really fast, right? Because the torque and speed is inversely related. So you can like change that and change with different ratios when you transmit power. So another use of power transmissions is for packaging, and with this packaging could also help with a better center of gravity. So on the right, you can see a picture of a chassis, and in this picture, you can see how like I packaged all the motors at the bottom of the chassis, and this is only possible through power transmissions. Like you can see how there's like a ton of gears and pulleys and stuff like that everywhere. So essentially, this just lets you have like a more like a modular robot, and it just lets you keep your robots smaller. So that's the benefit. And then also, another use of power transmissions is you can use them to connect different mechanisms. So there's not a picture of this on the slideshow, but something that we did last year is that we had like a double reverse forward bar, which is a type of linkage, but basically just an arm that goes, or not a double reverse forward. We had a virtual forward bar last year. And then this, it's basically just an arm that goes up and down. And then because we wanted our drone launcher to also be able to change the angle, what we did is we connected our drone launcher to our virtual four bar. And that like let us keep like not use extra motors or servos to change the angle. So there's many different uses for power transmission.
That's 100% one use of a power transmission. Something I forgot to mention on this page was that you can use a linkage to transfer power, right? So often what teams will do is power one shaft to power a linkage, which will eventually push something else up. For example, a V4B virtual four bar or a double reverse four bar or just a regular arm. Okay. So now let's get into some do's and don'ts. I think we'll do the same thing. I'll take the do's. So when you're using power transmission, as Arsh said, you want to make sure that you're achieving the correct speed and torque balance, right? So transmitting power from one place to another allows you to gear up or down. So let's say we have a really heavy mechanism and we need to pull, let's say we have to hang, right? We have to hold ourselves from the rigging and pull ourselves up, right? But our arm doesn't have enough power to do that. And our motor doesn't have enough power to do that either. So what we can do is we can gear up and then have higher torque on our arm. And then using that, we can achieve like a proper hang. And then, for example, maybe we want more speed. Something that teams do is gear down so that they can achieve higher speed. You want to make sure that you're always tensioning your belts and chains. So this is something that we've learned through the hard way. In previous years, we didn't immediately tension our belts because we thought, oh yeah, it would be fine. They won't slip. But what happens is because it takes so much torque to lift some mechanisms up, your belt will actually skip and miss some of the teeth. So your belt is moving, but the second pulley doesn't move, and it doesn't allow you to actually move your mechanisms properly, and it can mess up all of your sequences, right? So you definitely want to make sure you're tensioning your belts. So belts will often come and they're a little bit looser than the size that you actually need. So you'll have to like push them in with tensioners, and we'll show you that in a bit too.
Also, before Neil continues, another way that you can tension belts is that, so let's say you want to tension a belt that's connected to a motor and a shaft. So what you can do is you can add slots for the mounting holes on the motor, and that'll make it so you can like slide the motor along the holes so you can adjust where it is. And that's another useful way to tension, I think, which is better in some scenarios.
Yeah, you could definitely try something like that. You want to make sure you're mounting your bearings properly. So this is kind of a little bit out of power transmission, but just in terms of shafts and when you're running them and you're directly driving them, or not directly, but when you're driving shafts, right? You want to make sure your bearings are facing the opposite way. So bearings have this thing called a flange, which is like kind of this lip towards the top. You want them always facing in opposite directions. So if I have the flange facing on the inside on this side, I also need it on the inside this way. which is the opposite way. And then if I have them facing out, you have to do the same concept. Choose durable belts or chains for the load. I think this is kind of referring to using chains. Using chain is like a lot more appropriate when you're trying to transfer lots of torque. So when you're transferring torque, it's often what happens is your belt will slip, right? So that's why you want to use chain, because oftentimes it won't slip and it's a better way to transfer torque instead of using belts. There's no better way to explain it. I think that's just how it works, right? Chains are just a lot better for transmitting torque than belts are. Using calculators to optimize your transmission is really important because, like for example, last year, our intake slides, if we didn't test the speed at which they came out fully, then we wouldn't have a properly working auto, right? So prior to actually building our intake and prior to adding it, we had to see how big our spool size was going to be to ensure that it was going out at the correct speed. And then finally, keeping components consistent is really important just to make sure that everything stays compatible and everything works together. All right, we can take the domes. All right.
Yeah, so now let's talk about some of the don'ts. And just before we get into this, just some clarification. When we say torque, because there may be some people who don't fully understand what that word is, torque is inversely proportional to speed. So what that means is torque is like, it's the actual force with which you're driving your mechanism versus speed. So if you have a very high speed motor, you barely have any torque, right? You see that inverse relationship there. But if you have like a very low speed motor, then it's geared higher, like a 1:13 ratio or something like that in the gears. That gives you more torque, and then you can, lift heavier mechanisms and stuff like that. So let's just go into like the rest of this presentation with that in our heads. So the first don't that you want to do is you don't want to misalign parts. So this is a pretty important thing for any power transmission, whether it be chains and sprockets, whether it be gear to gear, whether it's belt to pulley. When you misalign your parts, for example, like a planar gear, for example, right? One gear and then you have another gear that just mesh together. If they're misaligned, one, there's less like contact, there's less surface area being covered. So there's more of a chance of skipping. And two, it's just like it doesn't transmit all the power that you want, right? If you have two parallel belt systems, it's much better if they're like parallel like this versus like if one is offset than the other. Then all of the speed and the torque doesn't go through, and that's just like, not the right way to do things. You also don't want to sacrifice torque for speed alone. So let's say you have a mechanism which is kind of heavy, but you want to move it fast. You can maximize your power output by finding the perfect balance between speed and torque. You don't want to, go full torque, have zero speed, and then have your like an arm mechanism or some other mechanism on your robot be super, super slow just because you want to have enough torque. You have to find like the perfect balance between the two. You also don't want to skip maintenance. Like for example, if you have like belts and pulleys and usually they're like rotating off of bearings or something like that. You want to make sure the bearings like aren't dirty. There's no actual dirt between like the metal balls within the bearing that are helping it move. You want to make sure your whole system's like it's eliminating as much friction as possible, because then that friction isn't subtracting from your total power output from the end. You also don't want to overcomplicate your mechanisms. We learned this last year as well, but you don't want to have something super, super complicated in which you have to have multiple power transmissions. Like, okay, this will belt up to here, then it's going to chain to here, then it's going to have this other belt here, then it's going to gear to here, all this stuff. When you do that, it just increases like the maintenance you have to do and like how perfect your systems have to be. And there's also, Murphy's Law, right? Everything that can go wrong will go wrong. So every single part of that mechanism will most likely fail at some point in time. So it's like, it's not too good to have a super, super complicated robot. It's better to keep it simple. Make sure to have power transmissions for sure. Don't direct drive, but keep it as simple as possible. You also don't want to combine too many mechanisms. So like Arsh is talking about how our arm system moved our drone launcher, right? That was like just two mechanisms combined. You don't want to have like, okay, so when we move our outtake arm system, it somehow moves the arm system at the top, and then that moves the drone, and this moves that. You don't want to combine too much. Like once again, you don't want to chain all these things together, because then when one thing fails, all of that is going to fail, and you don't want that to happen. It's just overcomplicating everything. Like Neil kind of said, you don't want to use belt and pulley systems for high torque applications. And like kind of diving more deep into that, it's like the reason you don't want to do that you can get away with it, and I've seen teams get away with it, but it's much more recommended to do chains and sprockets, because what happens is when you're using a belt and a pulley, the teeth, right, that are in the belt and the pulley, sure, they're meshing together, but they're not as like deep, and there's not as much contact. So when it's under a lot of torque, right, and your belt wants to move, but your pulley won't move, or something like that, they can skip, meaning they can go over a tooth and they can actually pass over the little like groove that it's fitting in, like that. It can sort of skip like that. So you don't want that to happen at all, because then you're just losing power output and your like mechanism isn't going to move at all. When you use the chain and sprocket though, that chain is going to fit much more deeply into the sprocket. So like think versus if it's only contacting like this, see how my hands can kind of like skip, for example. But let's say your like chain and sprocket is much more deep. It can't skip anymore, so it's forced to move. So it can transmit the torque in a much more efficient manner. And obviously, finally, you don't want to direct drive, because let's say you have a mechanism that's out, like like linear slides extending out of your robot, for example. Or like, actually, that might not be the best example, but let's say you have some sort of like mechanism that's extending out of your robot and can be subject to either field elements hitting it or like another robot hitting it. When something hits a mechanism that's being direct driven, all that force and shock load goes directly into your motor or directly into your gearbox. And what that means is that obviously when a gearbox is subject to a lot of force, what's going to happen? It's going to break, right? You don't want that to happen, especially with servos. So you don't want to direct drive when possible, and also you can get much more torque output or speed output with not direct driving, because you can gear it or belt it to however exactly you want it to be. So you have to be very specific with this, but it can be very, very rewarding when you do it right.
One thing I wanted to also add in terms of combining too many mechanisms. For example, let's say if we have our DR4B on one shaft and then we have our linkage for our intake on another shaft or on the same shaft, right? Let's say our DR4B breaks. And then to get to that, you have to also take off the linkage, which is perfectly working, but you just have to completely disassemble it because your DR4B isn't working. And then it just causes everything to be like twice as hard, and it makes it very hard to maintain all of your mechanisms. And this is just also ties into not overcomplicating, right? You want to make sure that everything is simple and is easy to repair. All right. I think that's it. Okay. So, now the floor is open to any questions that anyone has. Any of the Don't Blink members will be happy to answer any of your questions. Yeah, sure. Tavish.
Well,
What's your
for speed, which power transmission do you think is the best?
Well, it kind of depends on the type of mechanism you're running. So for an ARM system, I think I would always recommend using a linkage. So anything that's like kind of big and you're trying to, it's like one of your larger mechanisms and you're rotating that on a shaft, you want to always use a linkage. But there are times where that isn't always the case. So for example, if you're driving linear slides, right? You're oftentimes going to belt that type of thing. So it is a larger mechanism, but you're not directly using a linkage, but you can use a linkage. So it really depends on the mechanism.
Yeah, like one more example could be like an arm system or something, not like a massive arm system that's extending out of your robot, but one that could be like your end effector or the ending mechanism on your robot. So obviously you have to take into consideration like space and everything as well. Obviously there are restrictions on the sizing of your robot. So then it comes down to, like there's a lot of things that you can factor into it. So it's like, let's say I want my arm system to be right here, but I also want the servos to be right here, because then there's more weight towards the back. My robot's not going to tip, stuff like that. Then you would use gears, right? The power transmission is like they're right next to each other, the shaft that is moving and your servo. But if you want your servo to be more towards the back of your mechanism, closer to the pivot point, which reduces the torque needed to actually move your like whatever mechanism there is, then you might use like a servo here and then belt it to the mechanism towards the end, because you want to conserve weight. So it really just depends on like your application, but typically we use like all of the ones that we've covered here. So
Got it. Thank you.
I think Nitish put a comment in the chat. So if chain is meant for torque, then is belt meant for speed? I wouldn't say that they're like inversely used, but I think just generally when you are in a more or a higher torque application, you want to use chains because it won't slip as easily and it will
Yeah.
cause you less trouble
The
as well.
reason that we use belts instead of chain or chain instead of belts for high torque applications is because when you're using a belt and you're putting a lot of stress on it, the belt will tend to slip.
Yeah, it's not really like one is meant for a specific case, but oh, what if we want more speed? Well,
Yeah, I think
then you can
belts,
kind of use like you can still use a chain if you want. It's just
yeah,
the thing
exactly.
with metal chain, especially in FTC, is that it's not as easy to get working as belt, for example. So for belts, right, you just run a simple calculation and you can just order the exact belt that you need. You can put it on and then you can tension or adjust however. Chain, on the other hand, there's a very like lengthy tool that you need to use. Not lengthy, it's like a small tool, but it's kind of finicky and it's hard to use. And then you have to get it on the sprocket, like fitting it on the part, fitting on the shaft isn't as easy. So it's not like one isn't meant for the other, but if it's like a very high torque application, like if we want to lift a mechanism that's like 5-7 pounds out of our robot, right, from 2 motors at the base of our robot, then we're like, okay, it's worth the effort to do this because we know it won't slip. But belt generally just saves more time when putting on a robot. It's easier to fix, and it's just easier, really. It just makes your life easier.
I think um one thing is like when you're spacing your center to center distance of 2 holes apart for when you're using chain, you want that distance to be a multiple of 8 because GoBuilder runs on an 8 mm pattern. So if you're using chain from one hole to another, or from one point of rotation to another, you want that center to center distance to be 8. If you're using GoBuilder or COTS parts, which I think most of you guys will be, that you shouldn't have to worry about that. But if you are switching to something that's more custom, make sure to do that, and like use that when you're actually designing. Tavish, do you have another question? All right, are there any other questions about power transmission, servos? We can show you a servo block as well if you guys would like to see what that looks like. Give me a thumbs up if you want to see what a servo block is. All right, we got some thumbs up. Let's check it out. Let me pull it up. If you guys have any other questions though, just make sure to raise your hand or just like type it in the chat.
Yeah, we can also like send some links or maybe show you guys now or later, depending on how time works out. Like some of these like calculations or whatever stuff we're talking about, like might sound like big and scary, like, oh, you're calculating this, but it's really like you're just clicking buttons and picking numbers, and then you can kind of get exactly what you want in terms of belts and chain and stuff like that. So maybe after we show you the servo block and stuff like that, or after you guys' questions.
So this is what a servo block is. And I don't think we, or am I unmuted? Yeah, I don't think we really talked about why servo blocks are so important. I think we talked about why they're important in terms of mounting, but they're also really important because they offer a bearing for this spline or this servo attachment, which is called a servo hub, right? And the same way that we need a bearing for the shafts that we put on our robot, we need a bearing for this servo hub because if we're rotating something really large and we don't have this, right, then this will shake around and it won't work as well and it has the potential to come out and break, and it's kind of what keeps everything stable and running in the same way every time. So you want to make sure that you incorporate these into your robot. This is a little bit of an older servo hub variant, I guess. In GoBuilder, they've started selling like a new type. So I would check both of them out. This is what we like to use because we think it's a little bit smaller and it works the same and in the same way. Yeah. Are there any other questions that you guys want to ask? I think we highlighted a lot of things about power transmission, but oh yeah, there's another one in the chat. How would you start the process of calculating how much torque you would need for a specific application? Okay, yeah. So there's this site called Recalc, which I can pull up. Arnav, do you want to talk about it?
Yeah, so you can just send I can just send recalc in the chat real quick. So typically recalc, which is like a pretty useful calculator, it can help you find basically any sort of metric or measurement you need, like torque and speed and stuff like that. Mostly for us, it's not like we calculate the most specific torque ever and get our pulley ratio and servo for that purpose exactly. Mostly we kind of just look at the weight at the end of a mechanism or something like that, or just going off experience. So if we go axon servos, for example, right, you can find how much torque output they actually have and how much speed, and then just based on the weight of our mechanism and some brief calculations, we know that the torque output that the Axon Max has and the overall power output is more than enough for whatever thing we need to do. So we kind of just put it on there. So, but this is it's a very basic calculator to use. You can see this is for spool diameters. You can calculate this for linear slides extending, but you can see there's all sorts of stuff. There's Neverest, which is a different type of motor. It's actually from Andy Mark, another vendor. So there's a lot of different ways to do it. It's not super deep. We just want to make sure you guys don't pick if you have a mechanism, right, all the way at the end of some sort of arm system, obviously you're gonna need more torque, right? It's like moving a door from its hinges closer to versus further away from the door, sort of that example. So you can see the different torque you need to exert. So we just want to make sure that you don't go build a speed or super speed servo for some sort of application that requires a lot of torque and force to move. Like if your end effector is very heavy, you have some sort of arm mechanism, right? There's a lot of weight here. There's this whole arm system in your pivot point. You want to make sure you don't pick a speed servo for that. You pick something more suited for torque, and then you'll be good. It's not like they burn out that often, only if you make a decision like that where it's blatantly obvious you're not picking the right servo. So
one thing that we would suggest is when you're using for your drive motors, the ones that are actually powering your drivetrain, you want to use either 13.7 to 1 ratio motors or 435 RPM or 19.2 to 1 ratio motors, which is 312 RPM. These are both GoBuilda default motors that are sold. So this is what we use this season. We're probably opting for 300 or 435 RPM motors because we think it's all about speed, right? But for example, in a season like Power Play, or maybe not Power Play, what season would you use 312s in?
oh, we did use it in power play.
Yeah, but
because yeah.
I feel like you could have used 435s in Power Play too, right?
Yeah, well, Fray Frenzy is another good example. So robots typically in a game where there's a lot of robot on robot contact, right? Like
Oh
Fray
yeah,
Frenzy.
yeah.
You guys probably weren't even around for that actually if you're rookies. But you can search it up and watch some matches and stuff. You can also see us at Worlds in Power Play in the any of the semifinals or finals matches and stuff like that. So you can see that there's a lot of robot to robot contact. You know, we're pushing, we're trying to get each other out of the way. That's where you want more torque because going at a robot with a lot of speed isn't going to help. But if you have more torque, you can kind of overcome that robot's inertia.
Yeah.
So it really depends. The calculations and all the reasoning behind that has been done before, so you don't need to think terribly too much about it. Those are typically just the two alternatives you're gonna sort of oscillate in between. So
That's the reason why we chose 312. So you'll see 312 RPM. So your rotations per minute, right? They go lower when you have higher torque, and then when they get higher when you have less torque.
yeah,
So
and you can see the gear ratio as well, on there. So we say 13.7 to 1, right? That's a gear ratio. If you're going from a smaller gear to a bigger gear, the bigger gear is gonna move slower, but it's gonna have more force, so it can overcome more inertia or stuff like that. So you can kind of see that relationship firsthand. And we're speaking in GoBuilda terms because GoBuilda is just an amazing vendor for basically everything you need FTC. We highly recommend that you get any COTS parts you need from GoBuilda just because of the sheer amount of things that they offer. So
yeah. I also just want to let you guys know that we're open to any questions. It doesn't really have to be related to power transmission, obviously. That's what we showed you guys today, but we're open to answer anything for you guys.
Yeah, like if you have any questions about like literally anything FTC, we can even answer outreach questions if you guys have them. But it's like anything related to experience, you know, we've been around for a long time, so we know a lot about how things work. Anything with mechanical, any programming even, so like we're all here to answer. So just don't be scared to ask and ask as many questions as you want.
Even about this year's game. I hate this year's game.
Thank you, Ryan. No problem.
Thanks, Ryan.
Can you briefly go over how you would use the recalc belt calculator?
Calculator. Sure.
You want a screen share now?
Yeah. I'll show them for belts.
Yeah.
So I use the other one, this one. Or no,
Oh yeah, so this is we can send that link as well. So the
it's not
recalc belt calculator is not typically used that much, but are sent in the chat as well. The SDPSI, yeah. So
Yeah.
this also really yeah, Neil can screen share. So you just want to pick your like units and your pitch, which is really just typically 5 mm HGD
Millimeter.
is traditionally used. It's like just a good belt. It's not super thin that you know you have to deal with it, and it's like irritating and it can honestly like fade away quicker. But it's oh shit, click something. But yeah, 5 mm HGD is like it's like the perfect thickness and size that you need. And the
So
pitch is really just the difference, the distance between each tooth on the belt.
yeah. So the cool thing about this is like it'll fill in the thing that you don't have. So let's say our ratio, we can figure out a ratio. So let's say we're running like a 16 to 24. We don't even have to fill that out, honestly. So if we put 16 tooth pulley here, and then we're running a 24 tooth pulley here, and our center distance is around 128, right? So now we know that we need a 70 tooth groove timing belt, and just in this way, you can put it into V belt guys or any other vendor that sells belts, and you can from there find out which belt you need and then order.
Click the belt versus center distance as well. Like click that
Yeah.
thing, yeah. So this can also show you how many like grooves you need for each center distance, because on occasion like whatever distance you have between your pulleys, it can be like very abstract, right? It
And it's
might
like
not exactly line up, so it can show like
Yeah.
it can show you the number of grooves and everything and like the most optimal one. So sometimes what we do is like typically like we talked about tensioning belts, right? What that means is like two pulleys, you have a belt but it's not super tight. So what you can do is instead of your belt is typically like an oval, you can put a tensioner here so like the belt is like circular here and then it sort of converges like this, and it just makes it tighter around the pulleys and it decreases your slack and it makes sure your belts are like
and
they have enough tension in them.
reduces the chance of slipping as well.
Yeah. You don't want them to be too loose because then they can skip. So you
Yeah.
can see like the number of grooves here, like whatever distance, like 127, right? It might not be like exactly what we want. So what we do is if it's not exactly what we want, we usually see the next increment or the next tick that's higher, and then we're like, okay, the optimal center distance for the X number of grooves, like for 72, for example, like 128, right? It's much. Well, actually, it'll still be closer to
Yeah, it's 129.84. So maybe
so it's not exactly that measure, but we know that okay, we can tension the belt enough that it can still be tight around those two pulleys and it won't skip. So that's kind of the other mindset you need to have, because obviously not every distance you put in here is going to be listed on here, right? They don't make the belts for us, they make it for everyone. So you just kind of have to adjust to that.
checking this is actually really helpful just to make sure that you're buying the correct belt.
Yeah, and you want to make sure like it's also good just to see like to make sure you have all your numbers inputted correctly, because on occasion we'll forget to input some random number or something. We'll get like a crazy like 300 grooves or something. We're like, that doesn't make any sense, right? So make sure to click belt versus center distance. It'll still give you the most optimal thing down at the bottom and belt, but it's this is also a pretty useful tool to have. And
So
timing belts are just like, that's just the word used for the belts with teeth.
yeah,
Like,
and then the round ones are
yeah, round belts are called round timing belts. So obviously that's implied in the name what it is. But this is a very useful tool. So we'll make sure to send it in the server as well
one
for the
thing.
people who can join today.
One thing that's kind of good to note is that you're usually going to use like these even numbers, so 16, 20, 22, even 18, 24 tooth pulleys. You should try to stay with these like regular numbers rather than opting for numbers like 23 or like 25 because it'll often like screw this up and it'll make it really difficult to find the correct pulley size and or the correct belts and ones that will not slip as often. Yeah, we'll send that soon. We'll keep this running for a couple more minutes, but if nobody has any questions, then we'll end it off here.
Yeah, if you guys think of any questions later, you can just like ask them on the Discord server, and we'll be happy to respond there as well.
We're always responding there. This meeting will be posted in a couple minutes.
Yeah, I have a question.
Yeah, sure. What's up?
So, for in terms of belts, would you like recommend like going to like a vendor like the V belt guys or like to get like the exact like closer to the exact number of tooths compared to like a Go Builder that you can only get like every other like 5 to like
So,
15?
So we use V-Belt guys because it gives us more because we build custom robots, so it allows us to have more modularity. So we can have like a different motor in a different location. It doesn't matter. We can still find the correct belt for like that application. But one thing to note with V-Belt guys, it sometimes does take a little bit of time for the belts to come, which is like one trade-off. So just be
Yeah.
wary of that.
Generally, like Neil said, we have like obviously we like to like CAD or design our entire robot before actually building it and constructing it. So obviously we have very like abstract distances and stuff that just settling for something on COTS isn't gonna work. And also VBUG guys just generally has that quality that we're looking for in the sense that they reinforce their belts with like aluminum wiring throughout the actual body of the belt and stuff like that. So in terms of just quality and freedom with what belts you want to get, we've traditionally went with V-belt guys. Yeah.
Got it. And when you use them, do you need to do as much tensioning as you would otherwise, or is it very minimal?
I think you should still like always tension your belts. Like I think even if it's is as fast as Go Builder these days. Okay, so never mind. I guess V-Belt guys is getting a lot faster. But yeah, in terms of tensioning, I think no matter where you get it from, you just always want to tension your belts. It's not ever going to be consistent because there's always going to be a little bit of room between the belt and the pulley in reality, even if it isn't in CAD or in design. So I would always make sure to tension your belts, even if
Yeah, it's like not always certain that whatever you order you're gonna get. Obviously, there's still errors that can come from like V-belt guys and stuff. It's in the name. They're just a bunch of guys making belts. So it's you should always leave room to tension. You don't always have to tension. Like we don't always tension every single belt that we have, but we always leave room for it just in case because it's like not as predictable that you're gonna get exactly what you ordered.
like one example is that when we are one example of not tensioning our belts is for our intake. It doesn't necessarily have to be um super super tension and all the like teeth have to be touching exactly because as you'll see there's less torque in that mechanism, right? Intakes are usually higher speed and are rotating much quicker. So you don't need all of your teeth touching. It doesn't have to be super precise. They just have to be latched on and it has to be spinning. So yeah. Are there any final questions that we want to be answered?
How do you tension your belt?
Okay, yeah, that's a great question. So I can show you what GoBuilda has for that. So let me share my screen. So you can use this type of acetyl timing belt idler. Basically, they're called idlers. And what you do is you have like in the path where your belt is going to be, you have slots, right? And then on one of those slots, you can put a standoff and then this idler on top of the standoff, and then adjust the like how in your standoff is on that slot, and then continue pushing into the belt with your belt in this little cavity, right? And then the more and more you push into it, the more tensioned your belt will be. Obviously, like it depends on how tensioned you want it, but this is how you do it. Here's an example of what it looks like. You can use these with plastic chain as well. There's one more thing that GoBuilder does. It's one of these. So GoBuilder sells these like uh adjustable tensioners, and they have once again a slot to basically angle.
I'm sorry.
Yeah, sure. Sorry, what's the next? Did someone have a question? Okay. All right. Well, I think we're going to end it off here. Thank you everyone for joining us. And please make sure to join next week at next week or next Sunday at 6 p.m. We're Don't Blink. And this is FTC Rookie Rescue. Rookie Rescue. Good night. Bye.
Bye.